Welcome back to The Tech Between Us. We're continuing our discussion on the smart grid with Chris Irwin, Program Manager at the Office of Electricity within the U.S. Department of Energy. To catch up on part one of our conversation, visit our Empowering Innovation Together website.
Looking at the new grid, what are the more prevalent methods of communication? And I remember this is going back decades now, with the smart meter, Zigbee was going to be kind of the thing that was going to be connecting my smart meter to the power company. And I could give them more detailed information and they could in turn come in and control to some degree my energy usage. Is that still a thing, or have we gone beyond that now?
Zigbee still lives.
Okay.
It has new names, and it's moved around a little bit. So Zigbee was on the grid side and on the customer side. And then as the Internet of Things has arisen, it's actually moved into those home environments. And so I believe that Zigbee is inherited under the Matter system that has moved through there. But you're right, in some survey work that we've done with electric utilities is that they may use over a dozen different communications technologies to accomplish their aggregate communications needs, all the way from POTS, which if you know your geek antique terms is plain old telephone service. So we utilize a variety of unlicensed and licensed spectrum in addition to fiber and microwave systems, and of course, terrestrial radio, and even a couple of them have satellite failover capabilities. So it's intimidating for a utility to think that they have to manage 12 to 15 different comm systems to accomplish their mission when their mission is energy. But that's the law of the land today.
Yeah, it sounds like it's just the price of entry is that these systems are available to be tapped into and for two-way transfer of information.
One should not ignore the elephant in the room, which is, of course, the cellular service providers that are out there. And lots of grid operations and smart grid technologies do use cellular communications. But we also have to think about those black sky opportunities and things like that, because if your control is relying on the communications and the communications is relying on the existence of power, how do you exert control? How do you recover control when there's no more comms? And so there are limits to the utilization of consumer-grade communications, which have unbelievably wonderful bandwidth as you stream Seinfeld or all of your favorite things.
Right.
But if the power goes out, then Jerry goes away, and we need to keep communicating with our assets to bring the grid back online.
So from the cellular, are you guys using more the legacy network, or are you guys looking forward into some of the 5G networks that are being deployed with the new services?
No, we're using them all.
Literally every one of them.
Well, as we get pushed off of the low number Gs and stuff like that. So where we can, we use the least cost system that's available, and we try not to build our own systems and things like that. And so the 5G, the 4G systems are very serviceable for a lot of different needs. And so in those smart meters, you will find unlicensed technologies, the 902 and the 928 megahertz. You'll find a couple that move up the spectrum band a little bit, but still in the open public wireless. You'll have licensed wireless systems that go up to towers, and you'll have actually cell phone connectivity within a smart meter.
Now, are all those required because of fail-safes, or are all those required because they just transmit different types of information on the different bands?
I should make sure that this is clear. There are multiple smart meter vendors, and they generally only use a single communications medium within those meters.
Oh, okay. Got it.
But in order to differentiate themselves or to do something special or attractive to a utility, there's a lot of different technology choices, but they'll rarely have multiple comms paths in a single package.
Okay, now I understand. Yeah, so Company A could use 5G. Company B is still on LTE. Company C could use 5G, but with a fiber optic backhaul or something like that.
Correct. And you'll still find some of the customer communications, that Zigbee communication into a thermostat or something like that we started with a decade or two ago.
Right.
That still matters, but what you'll find is, the world has moved on to Wi-Fi. It's cheaper to implement and it's more ubiquitous out there.
Right.
And so in terms of those direct communications to the customer, that's what you use to talk to the customer if it's at that grid edge interface.
Once again, Wi-Fi being pretty much ubiquitous across the nation, across the world, actually.
Yeah.
So, Chris, it sounds like, and you mentioned this earlier, with all the communication and all the control that is going into the smart grid, it's really becoming a nationwide, gigantic Internet of Things system. Would you characterize it as that?
Yes, I think that we do recognize is that we actually have conductors and transmission lines across the entire United States. For convenience and for our own sanity, we do divide the nation up into sections. And so we have Northeast and the Midwest and the Southwest. So we do have some lines between the sections, but
Okay.
it is a nationwide network, but we operate it in a cellular fashion because it's a little bit more robust.
Right.
And it also allows, individual regions to express their own characteristics. As you may know, the Texas grid is isolated from the rest of the U.S. electric grid because that was the choice that they made from a self-determination standpoint. And so we have to respect some of the local things
Right.
as we have this nationwide network that we're trying to research into the future.
As things transition to more inverter-based platforms, the data generated, you had mentioned earlier about, each of these inverters could potentially be in itself a sensing platform to measure and to potentially control the grid. How much data are we talking about here? Are we on the order of exabytes like so many other applications, so many other industries?
I'm glad you asked that because I had the opportunity to speak
Uh-huh.
to the Office of Electricity's Electricity Advisory Committee.
Okay.
And so I talked to them a little bit about the data that the grid creates from minute to minute and second to second. So we actually do have an estimate is that the modern electric grid plus some of the market operations are operating on the order of about 38 petabytes of information on an annual basis. And so these sensors are taking measurements every second, every minute. There's a lot of different sort of cadences within it. But it's important for us to understand how much data is available to make smart decisions on the grid. How
Right.
much can we afford to bring back over communications networks to do smart things? And when does it become the smart move to move the intelligence out to the edge of the system?
Mhm.
And so in our future projections, by 2040, we project that we're going to have 36 exabytes of information that we could be operating on. And that's 1,000 times the information that we have today. And we're already slightly intimidated by doubling the size of the energy produced and consumed by the grid. So we've got our work cut out for us.
You mentioned using this data to do smart things. What sort of information would be available, and how would, say, a utility company or the DOE end up using that data for control or for measurement?
I think it's important for us to sort of go into the now and think about is that the grid is paid for every day and every year by the customers who pay their electric bills. And so we have an obligation to those customers to serve them first.
Okay.
One of the very sort of humdrum bits of information that we work on is power outage data. Many utilities have power outage data websites where if the power goes out, you can
Right.
go to the website, assuming you've got electricity, and see how widespread the outage is and things like that.
Right.
But one of the things that we've been working on at the Office of Electricity is to
Uh-huh.
make that a data service that is served up by the individual utilities so that you could actually have the outage announced on your phone or on the platform that you're using to look at things. And so there's a lot of public value by moving grid information out to people's fingertips. And so power outage data is a powerful one, and it's incredibly simple. And that's something that we're working on today and things like that. But like you said, is that inverter-based resources are by and large owned by customers. They are going to be proliferating with their solar panels and their, and their microwaves and their electric vehicles. So they have the power to sense things that we, as grid operators, don't need to place a sensor anymore. We could actually acquire a data service from a customer to have a monitoring function provided by them. And so, we have these gig worker sensors for the grid in the customer's hands. We need to sort of respect the customer and their capabilities because they're going to become increasingly important to the functioning of our system. One thing I didn't lay out in that data forecast into the future is that half of that 36 exabytes of data in 2040 is going to be available from customer-owned inverters,
Okay.
customer-owned electric vehicles. So the democratization of the electric system is a reality.
That is interesting because at that point, if the customers own the generation of the power, how does that affect the relationship with like the utilities and things like that? Does it change it at all, or is it just another layer on top of what's currently available?
I've worked on this problem for quite some time. We have this incredible resource that exists behind the meter, but the only investments that regulators can control are the investments that utilities make.
Right.
Electric system regulators can't make customers do certain things.
Right.
So we have to figure out how to allow utilities to utilize customer-owned capabilities, if needed, compensate them for the courtesy of that service, but still arrive at the end of the day of an increasingly reliable, increasingly resilient system. So there's a lot of balancing to go out that. You look at a company that has no assets and offers a major service, which is companies like Lyft and Uber, where they own virtually no vehicles, and yet they offer a transportation service. They are coordinating through economic incentives and wonderful technology and things like that. The free actions of independent drivers on the system, and they produce a pretty reliable and economically attractive system.
Absolutely.
It's not up to the reliability levels of the electric grid, and that's where their inspiration ends and our challenges begin.
Okay. So in talking about the V2G network, the vehicle to grid network, the utility company, in order to be able to use someone's EV that's plugged in as an energy source, would somehow need to have an agreement with the owner that they would be allowed to do that. And they could either compensate the owner or make a deal or something like that. And that's got to be done across individual houses, each individual house on the network.
Said that way, it definitely seems very, very daunting. But
Right.
of course, all of those wonderful electric vehicles are already basically internet connected.
That's true. Yep.
The vehicle manufacturers own telematics, and the telematics were to make cars more reliable, report their problems, do all these other wonderful things. So there is connectivity there, and there's ways to scale that doesn't have the utility going door to door saying, do you have grid services? Do you have grid services? And so there are definitely ways to aggregate and scale these capabilities in ways that are much more efficient. But again, it sort of goes back to is that these customer-owned assets, they have connectivity, they have data, and they have energy capabilities, and we can make a reliable system out of them, but it requires some transformation on our part as well.
Right. Transformation of both control and communication, as well as I would think policy at some point in time would need to change a little bit to take all that into consideration and use it effectively.
Yes, and so that's certainly the case in general with independent generation. And utilities, if you have, let's just say, half the populace in that city has their own generators because they felt empowered and they were on sale.
Right. Okay.
The regulators don't give the utilities any credit for having a resilient populace, that if the power goes out, they have ways for punishing them for being too unreliable and things like that. So you're right, there are some policy and regulatory innovations that need to recognize it's like, oh, if a customer has an electric vehicle and a solar panel, they might not care about an outage when they're parked at home for 1 hour, 2 hours, or 2 days. And so we don't have any legal mechanisms for recognizing value or figuring out how to ask them to participate in a more resilient system.
Okay. Yeah, that was actually a discussion we were having here in the office. A couple of our guys have EVs. I mean, I don't think they're the ones that can actually turn the power around and provide power to the grid. But one of the guys was saying, so there's no way in the world I'm going to give anybody direct access to my EV to suck the power out of it. I'm thinking, well, everything kind of depends on that, though.
When you frame it, it's like, hello, I'm from the government. Can I have your energy, please? It's just so doesn't work.
Right.
But you do have these free market mechanisms that take willing sellers and willing buyers and pair them up. And so in that electric vehicle context, if there's people who are willing to drive 5 to 10 miles out of the way for cheap gas, they have that economic motivation to park that car at home and defer charging until midnight. And in the morning, they're at 100%. Nothing has changed, and yet the grid is better off because they didn't start drawing 7.2 kW, 19,000 watts as soon as they plugged in at home at 5 o'clock p.m.
And then for them, they got an extra 20 in their pocket just for really doing very little that they wouldn't have normally done.
Yes, and so you take that Uber and Lyft example, and this is a population of people who have a vehicle to drive, and they're willing to donate their own personal time to work for this company. In the grid sense, you don't lift a finger. Your asset does a little bit of interaction with the grid, and you go on streaming the movie and having a nice dinner while your vehicle is earning money for you from the grid. So that's the kind of incentives where we need to get them right to make that system happen. But we've already seen examples in society where that kind of happy medium can be met.
Right. Absolutely. And I think, like you said, there will be people who won't, but then there will be a lot of people who will want to be able to do that for one reason or another.
Well, I think that most people's fathers would be willing to drive out of their way to save a couple of pennies on gas. And so we already have our first demographic picked out, Raymond.
Thank you for listening to this episode of The Tech Between Us. To dive deeper into the smart grid and explore Mouser's rich content on this subject, visit our Empowering Innovation Together page for videos, technical articles, and more at mouser.com/empowering-innovation.